Hi, good morning. In previous video, we have discussed about the introduction to Arduino. That comes under the unit to microcontroller and interfacing techniques for IoT devices. Now we are going to see about an introduction to Node MCU. Node MCU is a direct Wi-Fi module board. It has a voltage of 3.3 volt and Wi-Fi direct connections. Current consumption is 10 microamps and 70 microamps. Flash memory attachable. It is integrated at TCP/IP protocol stack so that we are connecting to the Wi-Fi connections. Then processor is a Tensilica L10632-bit and processor speed is 80 to 160 megahertz, and the RAM has a 32K and also plus 80K. It has an inbuilt GPIO pins of 17. It is multiplexed with other functions also. It has an analog to digital pins of one input with 1024 step resolutions. And what is first of all, what is Node MCU? Node MCU is an open source software and a development kit based on a ESP8266 Wi-Fi module. It is designed to enable an easy development of IoT applications and projects, providing a low-cost programmable platform with built-in Wi-Fi connectivity. Now, while coming to the hardware, Node MCU board typically features a microcontroller which includes Wi-Fi module, GPIO pins, and other essential components for interfacing with various sensors, actuators, and peripherals. This board is compact and lightweight and making it suitable for embedding into projects or connecting it to other devices via USB or serial communications. This is the Node MCU board, and we have a different pins. We have discussed it with later. This first of all we have to install Arduino board we can directly download it from the internet. This is the installation process that I have explained here. After installing, we have to select in tools. We have to select generic ESP236 module. Then we have to select generic module. Then while coming to the USB serial connection, in tools part we have to communicate. We have to select port, which port we are going to communicate with this module. We have two ports, COM1 and COM2. We have select COM1. This is a sample program for LED blinking. We are connecting it via a Wi-Fi connection. For step, this is a program. 15th pin as an we have made it 15th pin as an output, and 5th pin as high, and 15th pin 5th pin as output. In that we have write it as a high and a low, and we have given some delay so that we can see the output. This is the program. We have to connect via Wi-Fi. We have to establish these connections through this program. It has an username and password like SSID and password. We have to given so that we can connect the Wi-Fi directly. Later, we have to connect. We have to give the IP addresses and a Wi-Fi local IP. We have to give so that we can establish connections, and we can directly communicate with that coding with the directly communicate via Wi-Fi. This is an ESP32 board. It has an Wi-Fi module, GPIO pins, and microcontrollers, and various types of sensors and actuators can be directly connected. And it has a software also, which is easy to learn and well suited for IoT applications. Node MCU also supports programming in C and C++ using Arduino IDE. Other development environments offering greater flexibility and compatibility with the existing libraries and code based. This is first way. Now we are going to see about what is ESP32. ESP32 is a series of low cost and low power systems on a chip microcontroller with integrated Wi-Fi and dual mode Bluetooth. It has a CPU of extensor dual core 32-bit and a LX microprocessor operating range of 160 to 160 or 240 MHz. It has a wireless connectivity like Wi-Fi and Bluetooth. Programming Node MCU involves writing scripts or uploading compiled code to the device to define its behavior and functionality with a built-in Wi-Fi support. Node MCU can connect it to local network. We can send and receive data to over the internet and interact with web services and APIs, making it a powerful platform for developing smart device and home automation systems and remote monitoring solutions. This is and it has an integrated crystal of 40 megahertz and model interface of UART, USART, SPI, I2C protocols. These protocols can be also used here, and it has a ROM, RAM, and integrated connectivity protocols like Wi-Fi, Bluetooth, BLE, on-chip sensor, operating temperature range of 40 to 85 degrees Celsius, operating voltage is 3.3, operating current is 80 microamps. This is the ESP230 pin models, and it has an GPIO pins. Then it has a transmitter and the receiver pin. And we also touch sensors can be connected to the ADC4 and ADC5. That means 7 8 pins, and analog to digital converter has a pin of 9 and 10. Um, 16 and 17 is connected for transmission and reception, receiving and transmission purpose, and it a 19 pin has an input voltage, and a second pin has an reset pin and enable pin. Mm, 26, 23 to 26 pins are analog to digital pins. These are the pins that we have in ESP32 module. ASP32 peripherals include 18 analog to digital converters and 3 SPI interface, 3 UART interface, 2 I2C interface, 16 pulse width modulation output channels, and 2 digital to analog converters, and 2 I2S interface, and 10 capacitive sensing GPIOs. This is the input pin. These are the pins that have only input, and GPIO 34, 35, 36, and 39 and only input pins. These pins don't have internal pull up and pull down resistors. They can't be used as output. So these pins has to be used only for input purpose. SPI flash integrated on ESP-W32. GPI 6 to GPI 11 are exposed in some ESP32 development models. However, these pins are connected to the integrated SPI flash on SPI W32 chips and are not recommended for other users. So don't use these pins in projects. These are the internal touch sensor pins that are inbuilt having in ESP32 module. GP4, GPIO02, GPIO 15, 13, 12, 14, 27, 33, 32. These pins are the internal touch sensors. These are have sense variations in anything that holds an electrical charge like human skin, so they can detect variations induced when touching the GPIO with your finger. These pins can be easily integrated to capacitive pads and